Welcome to the SMYB YouTube channel. This is Kenneth Murphy, and today we are going to give our first try at making a stainless steel knife. A buddy that I used to work with a while back asked me to make him a knife while he's rafting down the rivers. I told him I couldn't because I couldn't do stainless steel, so we're going to give it a shot today and make a river rafting knife. What makes it unique is that it has a rounded tip on it, so you can't poke things with it. Makes it kind of interesting. So let's give it a shot and see what happens. I've hired a couple of voice actors to narrate as we go through this, so take it away, Ollie and Ollie from England and Australia.
Thank you, Mr. Murphy. This should be very exciting. Let's begin. Step 1. The first thing we have to do is cut out the general shape of the blade. The steel is received in the annealed state, which is as soft as it can get. So, we will use this Milwaukee deep-cut bandsaw mounted to this sweet Swag off-road stand. Now, we will refine the outer shape on the 2x72 belt grinder. We love this one from readerproducts.com. They don't sponsor the channel, but this grinder kicks butt. We need to mill out the hole for the bottle opener on the back of this knife. Kenneth is still learning how to use this milling machine. Let's cross our fingers that this 1/8 inch end mill will survive this process.
Phew. Looks like he got lucky this time. Crikey.
Refining the hole to smooth out the crappy machining. Starting out with a round file and finishing up with a die grinder and a carbide burr. This is stainless steel foil. It's used to make a packet to put the blade in during heat treatment. The stainless steel needs to be isolated from oxygen during the hardening process to prevent decarbonization.
Hey mate, I thought this was his first stainless steel knife. Why is there a piece missing from that new roll of foil?
Good question. It turns out that Kenneth isn't very good at estimating how much foil is needed to wrap around the blade and have 2 folds on each side to seal out the oxygen. I'll bet you 10 quid that the first piece that is too small is in that box.
Let's go over here. Okay. Give you a look-see here. We got programmed a thing on here. I hate frame rate stuff. Anyway, this is a program for AEB-L. I chose 1975 for the austenizing temperature. Hold for 15 minutes, and then we are going to plate quench in this super custom aluminum plate quench thing that we have. We got the air standing by. We're going to plate quench in here, and then when it's down to room temperature, we're going to put it in the acetone and dry ice concoction we got over there. I'll be back with you then. Okay, here we go. 20 seconds to go. Oop, 10 seconds to go. We're going to pull that knife out and quench it in the aluminum plates. 3, 2, 1, click. Okay, this is going to be really fucking hot. Holy Jesus. Come on. Air. I need to do this.
Dang. He's noisy. Watch, I'll bet the air compressor kicks on. Be careful, Murphy. That could still be hot.
Cooled off pretty quick, man. I couldn't believe it.
We can't hear you
Downhill
because
100
of the
degrees,
air
just like that.
compressor. For heaven's
Let's go over
sake.
and cut it out.
What he is
There you
saying
go.
is that he is surprised by how quickly the plate quench cooled the blade down to less than 100 degrees.
Look at that. Woo-wee. Oh, just one little bit of discoloration right on the tip. On the tip. It's my first time, so let's see what happens here. Kind of want to put a file on it first and see what it looks like. Can't see. There we go. Oh wow.
Damn,
Okay.
that sounds hard.
I think I'm going to go ahead with the other. I'm going to put it in the whatchamacallit.
This part is very dangerous. Kenneth told me that the acetone was very reactive to quick temperature changes and boiled over several times while preparing for this cryogenic treatment. Spilling acetone that is chilled to -100 degrees Fahrenheit all over the floor can cause burns, not to mention the fire hazard. He said that he will be using a different medium next time.
That's crazy. Dang.
take a look. So it's filled up. Thankfully the ice displaced the acetone enough that it finally covered the very back end of the bottle opener there. But we have a few solid pieces of ice down there. We're going to put the lid on, let it sit for a couple of hours. All hardened and tempered. We're going to flatten off this side, and then we're going to put some stuff on it, trace some lines, then we're going to groove, and we're going to start finishing, and then the handle. Okay, I got to do a little voiceover here because my recording on the film got screwed up. So basically, I'm measuring the height of the bevel and the thickness of the blade, and I'm using this spreadsheet right here that I made to help determine what the angle is to set my jig up to grind the angles into this blade. So the three things that you need to measure is the thickness of the stock and the height of the bevel. And then you have to decide how much material you want left over that I'm pointing at right there. The thickness behind the edge is what that's called. So there's a lot of things that go into it. Get out of there, Trump. There's a lot of things that go into it to how strong the cutting edge is versus how well it cuts. Too thin and the blade is, the cutting edge is fragile. Too thick and it doesn't cut as well as it could. So I picked 20 thousandths to leave for the cutting edge and had 3/4 inch high bevels on it. So put it into that spreadsheet and uses some trigonometry to determine the angle that you need to set this jig up at. I made this jig, it's super, super fun, really accurate. But that spreadsheet is kind of funny because doing the math for the trig is one thing, but Excel only does its results in radians. So you have to put an extra step in there to convert radians into degrees. It's kind of an interesting little spreadsheet, but let's continue on. We're going to set this thing up at, I think it was 3.8 something degrees. Obviously the resolution of this angle finder isn't that good, so I got it pretty close on film, and then when I wasn't filming, I micro adjusted that thing to get it as close as I could. But yeah, super fun stuff. Let's continue on.
Now that we did our calculations, scribed center lines and bevel lines, and set our jig to the proper angle, we can start grinding the primary bevels. We're back on the RPI belt grinder using 36 grit ceramic shredder belts from Combat Abrasives. 36 grit belts help remove material while keeping the blade cool. Since this blade has been heat treated, we need to be very careful to not overheat the steel and ruin the temper.
If Murphy did all his calculations right, when the bevel grind meets the scribed lines on both sides, the thickness behind the edge will be exactly 20 thousandths. Do you think it'll work out?
He's now switching to 120 grit belt to get a better finish on the bevels. This will help reduce the amount of hand sanding, which we will see in the near future.
Whoa! Did he just flip off that blade? What the hell? Dang. I thought this was a family show.
It looks like he sanded way too far in one little section of the bevel, causing a deep groove. What an idiot! This will require a lot more work in the hand sanding process to correct that one little error. I can understand his frustration, that's for sure. Let the hand sanding begin. He is using wet-dry sandpaper wrapped around a flat piece of steel to ensure a flat, smooth finish while leaving the transitions sharp and defined. He is using glass cleaner as a lubricant to keep the grit clear and extend the life of the sandpaper. We didn't want to film the entire process because that would take an eternity. He started with 80 grit and stepped through each grit, ending with 400 grit before buffing. We are going for a mirror shine with this knife. After hand sanding to a 400 grit finish, we start with the stiffest buffing wheel and the heaviest buffing compound. You can see that Kenneth is buffing at an angle different than the last hand sanding direction. That way he can see when all of the 400 grit scratches have been buffed away. Then he will move to a medium wheel and compound and buff out all of the heavy scratches. The final step will be the soft wheel and magic purple compound to get a mirror shine.
Holy crap, Murphy. That makes a huge difference. Looking good, mate. Hey. It looks like he's chosen black and grey G10 for handle scales. That's cool, because when you grind it, a pattern shows up in the handle. This is going to be sweet.
To attach the scales, he is using 1/8-inch brass pins. To drill the holes accurately, he clamps one scale to the blade and drills through the knife to align the holes exactly. After the first hole is drilled, he installs the first pin before drilling the second hole. After both holes are drilled, he clamps the second scale to the blade, removes the first pin and drills through the first scale, through the blade and through the second scale. Then he installs the first pin all the way through both scales. He can then remove the second pin and repeat the process for the second hole. We have to shape and polish the front and rear sides of both of the scales now, because once they are installed on the blade, we will not be able to sand them without damaging the polish on the blade. Murphy will start by shaping the outside and then beveling them to add some sweet style and ergonomics. Attaching the scales with epoxy is a pretty straightforward process. Cleaning the parts before glue up is very important, so we use acetone. At room temperature this time. Ha ha ha. Kenneth mixes some black pigment powder in the epoxy to make it easier to see when cleaning up the squeeze out on the front and rear of the scales. After letting the epoxy cure overnight, it is now time to start shaping the handle to final dimensions. We begin by sanding down the scales to match the steel on the top and underside. Then we will move to rounding over the edges of the handles to provide excellent comfort for the user.
This is the part that I've been waiting for. I think he is going to be sculpting the handles and creating an epic pattern in the sides of the scales. Golly, I hope it turns out good.
Looks pretty sweet to me. After a quick buffing on the soft wheel, this handle will be looking amazing and completely finished. The knife is nearly complete, but we will need a sheath to hold this blade. We've chosen to make the sheath from a thermoform plastic commonly referred to as Kydex, a very popular brand. We've chosen a carbon fiber pattern sheet because, why not? This process is straightforward. Heat the plastic up until it is flexible and clamp it in some foam. It will then form around the blade and hold it tightly. Now we need to trim the pieces to hold the knife secure enough, yet allow it to be removed easily. The back side of the sheath has a long tab that will eventually be shaped into a belt clip. The two pieces will be joined together using eyelets. Here you can see Murphy drilling 1/4-inch holes for the eyelets and crimping them on the anvil in a sweet continuous shot.
Check out that awesome rounding hammer from Alex Steele.
As mentioned before, we will now be shaping the tab on the back side of the sheath into a belt clip or even a pocket clip. Using a heat gun, Murphy is heating up the plastic to make it flexible and wrapping it around a piece of steel to let it cool and lock into shape. A knife cannot be considered to be a knife unless it is sharp. So let's do that now. Murphy is using a wicked edge knife sharpener and diamond stones to put a masterful edge on this blade. The first challenge is to grind through the flat 20/1000 edge to an apex. To ensure we have apexed the blade, he will be using a digital microscope to inspect the edge periodically.
Oh, no way, mate. That is epic. I love that view of the cutting edge. Hey! That was Evelyn and Ellie. I wondered if they would make a cameo in this film.
Almost done. We are now going to engrave on the blade using a laser engraver. This is the Atom Stack 70 laser etching the SMYB maker's mark into the blade.
Don't look into the light, Carol Ann.
That's it for us. We will now turn it over to our master craftsman, Mr. Murphy, to close out the video. It has been a pleasure joining you on this epic journey. Farewell for now. Say goodbye, Ollie.
See you all later, mate.
There we go. We are done. Here is the blade. Did some laser engraving on the back here. America. A special message for the handmade especially for you by SMYB. Let's pull it out. Kind of hard to do one-handed when it's not attached. Look at this. Focus. Focus, you bottle opener. Beveled on this side, a little dirty. Stand by. AEB-L. There we go. It's done. And now, the other parts that come with it. A few pieces of steel that came off of it. I don't know. This one went here or something like that. Yeah. I think this one went here. The template, hand drawn, just decided to do whatever. Spare Kydex. G10. Black and gray. This all goes to the customer for this is all the parts that went into making it. So there we go. Successful AEB-L stainless steel knife. Specifically the knife for rafting for my buddy Josh. All right, see ya.